Friends of model trains, welcome to another video in our Digital for Beginners series. Today's video deals with our Z21 multi-loop, the reverse loop module, and in the second part of the video I'll still show you how to connect and feedback module section in the reverse loop, and what to look out for. So what is a reverse loop module and why do you need it? A reverse loop module basically prevents a short circuit when, like I set it up here, you come out of a track, run through a loop and return to the same track. The track voltage is bipolar. This means that you have positive on one side and negative on the other. When you drive around the loop, the polarity swaps and would cause a short circuit. Of course this doesn't work. That's why you need a reverse loop module that swaps the polarity inside this loop, and then adjusts the whole system so that you can continue driving the locomotive. The enclosed operating instructions of course also explain the connection. There are two connection types, one has short circuit detection and the other has detection using sensor tracks. The short circuit detection is the simpler connection type. Where the wrong polarity occurs, meaning a short circuit is detected, the reverse loop model reverses the polarity. In the version with the sensor tracks are short de-energized sections, and when passing over these de-energized sections, the reverse loop module checks whether the polarity is correct and then reverses the polarity within the reverse loop. That means there is no short circuit and it is a little more gentle on the material of the wheel sets. To install the reverse loop module, you have to disconnect the reverse loop from the system. Bipolar insulation of the track is important here. This means that both rails must be separated from each other with plastic connectors, and that there is no longer voltage supply to the reverse loop, because it is supplied by the reverse loop module. How do you connect the reverse loop module? On the one hand, you have the power input, where the voltage comes from the system, so outside the reverse loop. Then you have two contacts to the output, which go into the reverse loop. You also have four contacts for the sensor tracks. I will show you those in a second. And here, on the far left of the picture, you can see two contacts for the analog connection of the reverse loop module. To connect the reverse loop module inside the reverse loop, I used a normal feeder track, here the 42517. As I said earlier, one side must be completely fitted with insulating connectors and only then plugged back into the track. And it is important to always make sure that the transitions, the rail connectors, are really joined together correctly. This means that you should always check whether the rail head surface is smooth. We have our supplied 2 or 8-pole screw terminals for connecting our cables. Here you see the bipolar terminal for the voltage supply from the control center and then the 8-pole screw terminal to which the output is connected, which then leads to the reverse loop. You can see that the status light is blue, so the reverse loop module is connected and ready for use. If you now drive the locomotive into the reverse loop, you can see that the voltage has been adjusted and the locomotive drives around through the reverse loop. Then a check is done to see whether the polarity is correct. And you can see that we were able to drive through the reverse loop without a short circuit. In the instructions on page 7, you can see the drawing for connecting with the sensor tracks. What are sensor tracks? Sensor tracks are basically two short, de-energized sections where the reverse loop module has time to check the polarity. These sections should not be too long, because if you have a short locomotive and you enter the de-energized section, the locomotive could stop because it isn't supplied with voltage. Here I just soldered the cables right away, also with the colors as you can see in the drawing, to make it easier to understand. If you do this at home, you can either drill through here or solder a little finer. Or if you don't want to solder, there is our connection cable with the rail connectors. But make sure that the section doesn't get too long. As I said, it is a de-energized section. I now install the two sensor tracks into the system. Here we have separated 2 poles from the short circuit detection, and again separated 2 poles for the sensor tracks. The sensor tracks are now separated from the system at the front and back with insulating connectors. So, we now disconnect our system and connect this sensor track here like in the drawing. Here you can see 1, 2, 3 for insulating connectors. Again, make sure that the rail connectors are correctly inserted in the rail base so that no edges stick out. Then connect the whole thing again on the other side. Quick check, everything is fine. Yes, and always check carefully whether the connection diagram matches the soldered cable. I've now connected the 4 cables of the sensor tracks like in the connection diagram in the instructions. And of course I need the output of the reverse loop module again. I also connect it to the connector and screw the whole thing back on. And then I attach the connector to the module. Now we have connected our sensor track and reconnected the reverse loop to the output. If we now drive our locomotive into the reverse loop, we'll see that the polarity is reversed as soon as the sensor track is reached. This is somewhat easier on the materials. There is no short circuit when passing the separation point. Even now, when we see the locomotive moving onto the sensor track, the polarity is reversed again and the whole thing is connected without a short circuit. I hear this question over and over: I control my system with a computer, or I monitor everything with the feedback module. But how do I connect this feedback module inside the reverse loop? There is one disadvantage: you can only use this feedback module for the sections inside the reverse loop. Like here. If you only have one section, you need a feedback module for the reverse loop. Why? Because the output of the reverse loop module is connected to the input of the feedback module and the polarity of the input voltage is reversed, so that the correct polarity is restored to the inputs of the feedback module. Now I'll show you how it's connected. To connect the feedback module to the track, you can use the connection cable again. As I have shown before, simply pull the 2 cables apart, and then you have 2 connection cables for the feedback module. To connect the feedback module, you have to insulate a rail again. Insulation is provided by the reverse loop module and the metal rail connector must be replaced by one with a cable. Simply pull it apart and, as I've already shown a few times, it is best to grip the rail connector with a small pair of pliers and pull it out and then insert the other rail connector back into the rail base, then reconnect the whole thing. Quick check, it's fine. Now the second rail has to be connected to the detector input. You can use a connection cable to do this. In order to be able to show this better virtually, I'll now just take my second connection cable, reconnect the rail connector over there and show you how it works. Now the second rail is connected and the cable is also connected to input N, which comes from the multi-loop. As I said earlier, we can also use the feeder track, but because both cables are black, you always have to look carefully to see which one is connected on which side. It's a little easier to visualize it with the two different cable colors. To display the feedback module in the app, the feedback module must be connected to the control center. To do this, take the R-bus cable and plug it into the feedback module as well as into the R-bus in the Z21. I have now connected the app to the Z21, and when I drive into the reverse loop, the feedback module should display something. And look, the occupied message works. And now we drive through the reverse loop. The reverse loop module has reversed polarity. The occupied message turns off. When I drive back into the reverse loop module adjusts the polarity, but the occupied message still works. In this case, only one input of the feedback module was used. But of course it's also possible for the reverse loop to be much larger than it is here. Then you might have several sections in a row, or you might have a staging yard inside the reverse loop. I can then connect all the sections inside the reverse loop to the one module. An additional insulating connector has to be fitted for this purpose, and a second cable has to be connected to the feedback module input. This way you can monitor several sections in the reverse loop. So that's it on the Z21 multi-loop. Thanks for tuning in and see you next time.